Hopefully this is working now. Let's see if this actually will go through our sixth attempt. First off, let me say we miss you guys, and on behalf of all the teachers, we hope to see you guys soon. So let's take a look at these notes. We're going to go ahead and start off with our review of systems of equations. The first thing I want you to take a look at is Mr. Johnson's notes there. He has his steps, the first one being graph each line using the slope and y-intercepts, then find the point they cross or where they intercept. So again, remember slope-intercept form, y equals mx plus b, where m represents the slope and b is your y-intercept. As you can see, our system is a little bit messed up here. It should be 2x minus y equals 1. So let's go ahead and write that down. So 2x minus y equals 1. And your other equation is y equals negative x plus 5. The second equation is already in slope-intercept form. So I can easily identify my slope, which is negative 1. Remember that you need to put a 1 underneath it. This now will tell you that you're going to go down 1 and to the right 1. And your y-intercept, which is your b, is 0 and then 5. For the first one, it is not in slope-intercept form, so I need to put it in that form. So I'm going to subtract 2x to both sides. Here's my zero pair. I now have negative y equals negative 2x plus 1. I don't want negative y. I actually want just y or 1y. So I'm going to divide everything by negative 1. I now get y equals 2x minus 1, which now lets me find the slope of 2. Again, don't forget to put a 1 underneath it, which means I'm going to go up 2 and to the right 1. And my y-intercept, my b, is at negative 1. I can now take that information, so let's go ahead and do the first one. And we'll do that one in blue. It is crossing at negative 1, so I'll put a dot there at the y-intercept. And the slope is up 2 and to the right 1. And as I told my students, you can actually going up 2 to the right 1, up 2 to the right 1. You can keep doing that all the way across your coordinate plane. In fact, I'll go in the other direction. I am just going to do it automatically because I can see a pattern. I'll come back later on and draw the line. Our second line, y equals negative x plus 5, has a y-intercept of 5. So we'll put a dot there. And then I'm going to go down 1 and to the right 1. Down 1 and to the right 1. If you notice, there's already a blue dot there. So I'm going to go ahead and circle that. Again, down 1, right 1. And I'm going to keep doing the down 1 and to the right 1 so that I can get more of my points. And again, going backwards, not giving it too much thought, just being able to see the pattern. I can now go ahead and draw my lines. And even if they're not 100% accurate, because I circled it, I can already see where they cross. So I'm going to draw my other one. And I can see that they have a point of intersection, or where they cross, at 2, 3. So if you can see on the next page, Mr. Johnson went ahead and figured it out. And he asked some questions. What is the solution to the system of equations? And again, we were finding the point where the lines intersect. So he did the same thing there already. Looks like he used a program to get that accurate. And so you can see that, again, they are crossing at 2, 3. By the way, some of you guys noticed that you actually could have done this using substitution. And so Mr. Johnson used y equals negative x plus 5, and he substituted it for y and the 2x minus y equals 1. And then doing it by substitution, he was actually come up with x equals 2. He substituted back in, and he got that y equals 3. So again, just review. Let's take a look at our objective. Students will understand congruence and similarity using transformations. As you can see, Mr. Johnson is writing down the rules for transformations. So if we have translation of left 3 and down 2, remember left is subtraction, right is addition. So that first one would therefore be, we're going to subtract 3 from the x-coordinate. And then for the y-coordinate, down 2, meaning down meaning subtraction, up meaning addition. So to the y, we're going to subtract 2. For reflections across the x-axis, remember that the x-coordinate will stay the same, but your y-coordinate will become its opposite. Reflections across the y-axis. This time it is your x that becomes its opposite, and the y will stay the same. We'll go to dilation because it's probably the easiest one after the other two. If we are going to dilate by a scale factor of 2, that means that we are taking the x-coordinate and multiplying it by 2. And we are also taking the y-coordinate and multiplying by 2. For a dilation of a scale factor of 1/3, we can do the same thing. We are multiplying the x-coordinate by 1/3 and multiplying the y-coordinate by 1/3. Or, if your teacher showed you this method, this will also work. Multiplying by 1/3 is the same thing as dividing by 3. And so x will be divided by 3 and the y will be divided by 3. Remember, if you are dilating by a scale factor that is bigger than 1, you are enlarging. And if you are dilating by a scale factor of 1/3, you are reducing. So less than 1 means you are reducing. For rotations, which is what you see up here, and I will put down here that these are rotations. I will first show you Mr. Johnson's method, that if we are starting here, so let's do the easy one first. If we are doing a 180-degree rotation, that means 2 quadrants over. Remember that your x becomes its opposite and the y becomes its opposite, and the x and y coordinates stay in the same position. If we are doing a 90-degree clockwise turn, the y and x switch places. So in other words, the y comes to the front, the x goes to the back, but it becomes its opposite. If we are doing a 90-degree counterclockwise rotation, again, they switch places, but this time the y goes to the front and becomes its opposite, and the x goes to the back and remains the same. If you are or were in the class where the teacher did the rules, they would look like this. So 180-degree rotation, your x and y stay in the same position. They just become their opposite. For a 90-degree clockwise, so CW clockwise rotation, your x and y switch places. The y stays the same, but your x becomes its opposite. And for a 90-degree counterclockwise, so CCW, again, they switch places, but this time it is your y that becomes its opposite, and your x remains the same. So again, just reviewing some of the notes that we have already done. So let's take a look at, and again, there are the notes that Mr. Johnson has filled out in case you want to look at them in a different color. So let's take a look at our first one. So if a triangle, or if triangle ABC is rotated 270 degrees counterclockwise, let's remember that 270 degrees counterclockwise is the same as 90-degree clockwise. So I need to remember that so that I can write the correct rule. So my rule is as follows. The x and y coordinate are going to switch places. The y will stay the same, but the x becomes its opposite. We are now going to locate our pre-image coordinates. So for A, B, and C, A is located at 2, 5. B is located at -3, -1. And C is located at 4, -3. I am now going to perform the transformation. So I am going to get A prime, B prime, and C prime. What I'm going to do is kind of try to develop a pattern for myself. I noticed that in the rule, the y coordinate goes to the front and it stays the same. So I'm going to do that all the way down. So the y coordinate is 5, I'm going to move to the front and stay 5. For the B, the y coordinate is -1, I'm going to move it to the front and I'm going to keep it the same way. And for the C, I'm going to move it to the front and again keep it the same. So I kind of made a pattern all the way down. So I'm going to do the same thing with the x coordinate. Right now the x coordinate is 2. It's going to move to the back and becomes its opposite. So the opposite of 2 is -2. For B, it is -3. Move it to the back, become its opposite. So it is a 3. And then finally for the C, it is a 4. It's going to move to the back and become the opposite of 4, which is -4. And so there are my 3 new prime coordinates. So I'm going to go ahead and put them up here where it asked us to put them at. So A prime is at 5, -2, which means you're actually going to be able to locate that in quadrant 4. For B prime, it is -1, 3, which means you can locate it in quadrant 2. And for C prime, it is at -3, -4, which means we're going to find that in quadrant 3. I am now going to plot those points. So A prime is at 5, -2, and it looks like it went a little bit off, but you can make a pretty good estimation there. So this is going to be my A prime. B prime is at -1, 3. So -1 and 3, there is my B prime. And C prime is at -3 and -4. So this will be my C prime. Once I have all of my prime coordinates, I can go ahead and connect. And there you have it. So in case you need to just find the coordinates or in case you need just to draw the transformation, we're actually taking care of both. So let's take a look at the first whiteboard problem. And it says, answer each of the following, write in arrow notation. If point CD is rotated 90 degrees counterclockwise about the origin, what are the coordinates of its image? So what we need to do first is I would suggest writing down the rule that you are familiar with. So X and Y. When I'm going 90 counter, remember they are going to switch places. And then, for example, 90 counterclockwise, the Y becomes its opposite and the X remains the same, but they switch places. I would now take the letters that they are using, so C and D, and we're going to do the same thing. They're going to switch its places. And the D, which is a Y, is going to move to the front, and it's going to become its opposite. The C goes to the back, which is the X, and again, it remains the same. So that's all you need to do for those. So what you will do with all the rest of the problems is practice that. And I'm looking here to see if there are any other notes that I need to give you here, and it looks like we are good. Don't remember. There you go. Don't forget, guys, that if you have any questions, you can go ahead and email your teacher. Our emails are the first name underscore and last name. So, for example, Joe_Morales at sangerusd.net. I know the teachers are checking their emails constantly. If not, they will get back to you as soon as possible when they do check their emails. Again, hope you guys are doing well. Hope you guys are safe. And we hope to see you soon.